Hi everyone, my name is Ida Ru from Marco Bernardi's research group at Applied Physics and the Material Science Department at Caltech. Today I'm going to walk you through about how to compile and install a Perturbo. Currently, Perturbo is interfaced with Espresso, and you will use some output file from Linear 90. So I will provide some quick instructions about how to compile Espresso and Linear 90. So the first thing is that we need to get a Perturbo source code. To get a Perturbo source code, we have to register as a user. So we have to go to the main website of Perturbo. And at the bottom of this page, then you will see that there's a instruction about how to get a source code. So I'm going to show you the main website. So here, this is a main page of the Perturbo website. So at the bottom of this page, you can see that to download the code, content as click here. So you just simply click this one, and you will get a pop-up window like this. Let me show you. So this is a pop-up window. And here, to register as a user, you have to provide your personal information. So here, this is a name. For example, my name is Ida Lu, and organization is Caltech, and the country of the organization is United States. I'm going to use Perturbo for studying ultra-fast dynamics in 2D materials due to electron interactions. And if you have a GitHub use account, then we will recommend you to register to provide your GitHub username. So in my case is Louis. And if you don't have the GitHub account, that's okay. We will just send you the tar file of the source code. Actually, we will recommend you to provide your GitHub username, because once we have a latest version of a Perturbo, then you will get the source code immediately. But if you don't have the GitHub account, then you have to send us this email again to get the latest version for the source code. Okay, so let's go back to the slides. And here, once you have the source code of a Perturbo, then we need to get the Espresso on Linear 90 and the HDF file library before compiling Perturbo, because Perturbo use some subroutines from Espresso to get to do the interface. Okay, so currently Perturbo supports Espresso version 6.4 and 6.5. And here we provide a link to get the Espresso version 6.5. If this link doesn't work, then you can go to Espresso website to download the source code or Espresso GitHub repository. So once you get the source code from Espresso, you change into the Espresso directory, and there you use a configure to generate a make.inc file. Once you have the make.inc file, then you simply type make pw for density functional theory calculation, and phonon calculation, pp for post-processing. So once you are done with Espresso, then we are going to compile Linear 90. Although Perturbo doesn't using any subroutines from Linear 90, it will read some output file from Linear 90. So we still need to install Linear 90. And here we change into the Espresso directory, and we provide a link to get the source code of Linear 90. And if this link doesn't work, you can go to a Winian90 website, or it is GitHub repository. So once you get a source code, you change into the Winian90 directory, and there they provide some example files for Make.inc. You just pick one which is more related to your system, and then you modify the Make.inc and simply type make. And once you are done with the Quant Espresso and the Winian90, another important library required by Perturbo is HDF file library, because Perturbo will store and output a very important data into a HDF file format. And we use a HDF file format because it is very portable from one machine to another machine. Okay, so you have to make sure that you have a HDF file library installed in your local laptop or your clusters. So once you are done with the Quant Espresso, Winian90, and the HDF file library, then we are going to install Perturbo. So we change into the Quant Espresso directory, and we get the we use a git clone to get the Perturbo source code. And once you have the source code, you change into the Perturbo directory, and there you will see there's a make.sys file. In this file, you open it, and there are two sets of very important variables to modify. One set is related to Fortran compiler. So here we provide two examples for Fortran compilers. One is Intel compiler, and the other one is Fortran compiler. And if you have other preference, then you can modify these two flags by yourself. Okay, so the other set of important variable to modify is related to HDF file library. So here you have to provide the paths to the HDF file include directory. And here you for this flag, you need to provide the paths to your HDF file library. So once you are done with the modification for the make.sys file, then you save the file and just simply type make. Then you will generate two executable program. One is called Perturbo.x, and the other one is QE2per.x. And you can see that this is the interface between Perturbo and the Quant Espresso. And this one, once you execute this one, you will generate a HDF file, which is required by the Perturbo.x. And if you have a third party, for example, other DFD code, then you can create another interface and generate a HDF file format that can be read by Perturbo.x. Okay, so now I'm going to show you how to compile Perturbo. So let me show you my terminal. So here you can see that I have a Quant Espresso on my local laptop. So I change into the Quant Espresso directory. And here you can see that I also have a Winian90 installed. Okay, so now we are going to compile Perturbo. So the first thing is that we need to get a source code. So I git clone Perturbo repository and list. Then you can see that I have a directory called Perturbo. So I change into Perturbo. And here you can see that there's a make.sys file. Okay, so I open it. And the first set of a variable we need to modify is related to Fortran compiler. So I'm going to use a Fortran compiler. So I comment out this, and I comment this one, and then comment out this one. Okay, the other set of variable flags to modify is related to the path to HDF5 library. So here I need to modify this. So I delete this one and I provide my path to the HDF5 include directory. And I also need to modify the, the library path. So I delete this one and I provide my library link to the HDF file. HDF5 file. Okay, so once I'm done, I'm save this file and I just simply type make. So the compilation will take around roughly like 1 minute. So let's wait for 1 minute. Okay, almost there. So at the end of the compilation, if you list, you can see that you have a bin directory. And if you change into the bin directory and list, then you can see that there are two executable programs. One is called Perturbo-code, and this one is using to compute the electron dynamics and transport property. And another executable program is QE2per.x. And basically this one, it will interface with Quantum Espresso Linear 90 output file and generates a HDF file output file. Okay, so let's go back to the slides again. So now we have a Perturbo installer. Then before running any calculation for Perturbo, and because we need to run DFT calculation, DFT density functional perturbation theory for Furlan calculation, linear 90 calculation. So you are going to have many input file and an output file for those calculations. So here we recommend a directory hierarchy for you to organize all the input and the output file in different from different source code. Okay, so let's say we are interested in silicon. So I create a directory called silicon. Inside this silicon directory, I create 3 subdirectory. One is called pwph1. This one is interface with in this one we will put all the input file and output file for Quantum Espresso and Linear 90. And the second subdirectory is called QE2per. This one is interface with Quantum Espresso and the Perturbo. And you will generate a HDF file called prefix underscore ep1.h5. In this case, prefix will be SI silicon. Okay, so this file will generate in this directory, and in the third subdirectory is called Perturbo. So inside this one, we create a child directory called perturb dash bands if you want to band interpolated the band structure using Linear 90 or Furlan dispersion calculation, etc. I will show you the calculation mode in Perturbo later. Okay, and The last thing is that, okay, so in the first directory, inside this one, you can we have a 4 subdirectory. One is called SCF for DFT calculation, Phonon for DFT calculation, NSF calculation, and WAN for linearization. Okay, so now this is the last patch, and I'm going to navigate you through the Perturbo website. So I'm going to show you where to find Perturbo tutorials and examples, and how to use the interactive workflow in Perturbo website, and where to find the definition of each input variables when you use Perturbo.x and QE2per.x. Okay, now I'm going to show you the website again. So here, this is a Perturbo website, and you can see that there's a tutorial. So if you click this one, and here in this tutorial, we provide silicon without spin object coupling as an example. So if you go to QE2per.x, then here you can see that all the steps to run QE2per.x. And here you can see we need to run DFT calculation, one-line calculation, NSCF calculation, and then do the linearization. So I'm going to quickly show you this step 5. So once you are done with the QE2per.x, at the end of this calculation, then you will get a this file called prefix underscore ep1.h file, and this file is required by the Perturbo.x. Okay, so now we are going to run Perturbo calculation. So here we show you the current calculation mode in Perturbo.x. So we have a band, which is to get an interpolated band structure using linear functions. To get a phonon dispersion using the force constant in real space, and electron phonon mesh cinnamon calculation. Setup is you will set up all the relevant variables for transport calculations, and in sigma means to get the imaginary part of self-energy for electron phonon interactions. This one is the mean free path calculation. Trans is to, if you want to get the carrier mobility or electrical conductivity, you can use this calculation mode, trans, and the carrier mobility and will be computed using within realization time approximation or iterative approach. Trans dash pp will give you the seedback coefficient, and these two dynamics dash 1 and dash pp are related to the electron dynamics calculation, and we will cover most of the calculation more in the later tutorials. Okay, so if you are not satisfied with this simple example, then we provide other examples. For example, we provide example for silicon with spin object coupling, gallium arsenide, a polar material, graphene, a 2D material, aluminum, a metal. Okay, so if you forgot the workflow of Perturbo, then basically you can go to utils, and here you can see the active workflow, and you can see the overall workflow of Perturbo. And here we do the DFT calculation, DFT, and the linearization. and we interface with Coin Espresso and Perturbo. And this is all the calculation mode I showed you before. So if you click here, let's say the interface QE2per, then at the bottom you can see that to run this calculation mode, we show you that what are the required files are needed in this in this calculation mode, and what kind of the output file you will get once you are done with this calculation. And here, this is an example input file. So you can just click this button, and you will copy everything, and you can paste this one to your terminal and modify the corresponding variables for your system. And let's say if you are interested in the electron form calculation, and you a matrix element calculation, then you click this one, then go to the button. Here you can see what are the required files, and then what will be the output file. And this is also the example input file. Okay, and if you want to know the definition of each variable, you can just click the one you are interested in. Okay, so now we also provide other utilities. For example, this one, yeah, it's a Python script. It will generate an input file for you. And this one, this is another Python script to convert the imaginary part of self-energy into the realization time and the scheduling rate. Okay, so the last thing is that if you want to know the definition of each input variables, you can go to the corresponding section. For example, if I'm interested in the variables for the Perturbo.x, it comes to this page, and we simply type, let's say, for example, I'm interested in the band underscore min, and I click this one, and you will bring to the corresponding variable. And here you can see that the corresponding variable type and also the meaning of this variable. Okay, that's all. Thanks for your watching.